Thank you for everybody are here or online. It's morning, I think, in US, really late night in Asia. But welcome for this afternoon. Here, I think, please stay a bit awake. I know it's after lunch. I try to make more easy this talk. We speak about robots with NVIDIA and all we can build a robot and what is behind in a really top-level view. No coding right now. And hope, yes, works, okay. Well, I'm technical marketing and community support for NVIDIA. I just forget my role. And let's speak about what something important for us is NVIDIA Omniverse. NVIDIA Omniverse is a platform for robotics, and not only for robotics, where there are many partners are working, example, with us. We're supporting open, the open source and open company. Example, we are supporting OpenUSD when we design a robot. You want import models, like import a model for robotics, like from your CAD. In this case, you need you have an external CAD. You want to import on your system. I imagine when I speak with you, a digital twin. You are working in a warehouse, you're designing a warehouse. I'm a big company or a small company. I have just many products to sell and I want a robot. Maybe a humanoid robots, because the robots are slowly coming, the humanoid robots, even in our life. And I want to use the power of the open source on my projects, example. And I can work with NVIDIA Omniverse, also with the third parts products, open parts, for design my application. I was speaking about digital twin. Maybe, I don't know, for everybody know what is a digital twin. A digital twin is an easy way to think a replicate world from a real world in a simulation world. Like I want to have a fully replica of my warehouse. I'm speaking about warehouse because imagine I want to make a robot here in this office. I can't reshape the building like in 1 minute. There are other colleagues are working. What I do, I replicate in simulation. This is my digital twin. I make a replica, I design, I test my robot, test whatever. When it's done, whatever I made in simulation, I cover and put in a real, in an office or in a warehouse. How it's worked in this world with NVIDIA? What we designed it. Working with NVIDIA's Axim is an open source system and software for robotics. You can work with the synthetic data generation and system in the loop, or hardware in the loop. You can bring the data, like I was saying, from 3D assets, teleoperated data, or real-world data, and I import in simulation. I can test what I want for my robot. Can be a wheeled robot or humanoid robot. I'm really picky about humanoid robots because after we will see other software related for humanoids. When I simulate my environment, generate my synthetic data, example, I want to train a network, I can use directly the data coming from real data and from simulation, and I can build my new model to control my robot. After I can test or in simulation, mixing with the hardware, and after, when it's done, I can use whatever, what I made, my AI, my controller also, on a manipulator or a humanoid. There are many things are happening, and the world requires more power, even not a real robot, even, example, if I work in simulation. And there are many ways. There are the simulation part, where I work with NVIDIA Omniverse, I was saying, when I'm testing, and Cosmos on an RTX. After I want to train my model, and I use an NVIDIA DGX or a HD GX. And also, I want to deploy what I'm doing on the real robot. Example, with NVIDIA Jetson Thor, that support and work with Ubuntu. Or the GX Orin, there is a really different type of hardware for different type of robot I want to use. From a wheeled robot, for a really massive utilization of power and AI, example with Jetson Thor. And like I was saying, we have a really big ecosystem related for Omniverse and for the physical AI. company in an open source environment, world, humanoid makers, robots and sensor makers, all together in this ecosystem can make bigger Omniverse. You can make design and testing with real software, real hardware, what is required for my robotics application. And let me back about humanoid robots. The humanoid robots, to be honest, I speak about what I noticed in the last, in particular year. I was surprised at how many humanoid companies are rising and making robots. And I remember I was studying, I have a Ph.D. in robotics and control theory. I remember making a robot was like difficult. Making a humanoid robot is like a dream. Now it's become cheaper. It's like, well, I can make a robot. I can directly buy in a shop. Honestly, I found in a shop. And I'm surprised. This is what this means. We need more AI. We need open source, more support for these humanoid robots, and for the startup are working and making humanoid robots. We made Isaac GROOT. Okay, and and Isaac GROOT is an open source platform with models related for humanoid robots. What is important? There are many things we noticed in the beginning. We have some data coming from web data, example YouTube, Reddit, whatever, and are real data. We want. There is also synthetic data. Yes, okay, the button works. I want to also generate other data for to drive my humanoid robot, because some application of the robot, the humanoid, are never tested. Like I want to open a bottle. Well, now yes, it's really tested. But there are other things that maybe a humanoid robot we don't have a lot of data. In this case, I can work in simulation to generate this missing data to train my network and work with Isaac GROOT. And also, I can work in teleoperation. There are some videos that are not running, but I can show what the meaning of this video. In this case, I can also work in teleoperation. I can drive manually the robot and record whatever I'm doing in teleoperation and use this data to train a model. What I can do now? I have my input, a sensor input from the robot, prompt coming, data coming from the simulation or from the teleoperation, and I use Isaac GROOT, such an open humanoid robotics platform, to generate the action I want for the robot. And all these things are running on a Jetson Thor. We are closing this loop, starting from a massive data center, like a simulation, a massive model. Step by step, I also close this loop. Okay, he's in a robot. He's using a Jetson Thor example to work on the robot. And there are many things. There are foundation models, example, on an Isaac GROOT. I also can train with Isaac Sim, like we have seen previously, and Isaac Lab for a multi-robot simulation. And, well, like I say, there is a Thor robotics computer, a board Jetson, defined for humanoids. Like we have seen in our general introduction, for Isaac GROOT, there is the simulation area where I can simulate on the open platform all I want the robot do. Stuff, example, pick an object in a ball or doing other interaction with humans. I train with the synthetic generation pipelines and Isaac Sim and Isaac Lab. And finally deploy on Isaac GROOT directly on Jetson Thor. Yes. There are many steps inside the GROOT. I can use on Isaac Lab GROOT teleoperation. I can teleoperate the robot. I can mimic what I made, example in simulation or in teleoperation in particular, what the robot I'm doing driving on the real robot. And I can generate the model and generate the videos with Cosmos as well, the 3D part, and testing and train my model. There are really different steps all open for the robotics and humanoid robot application. Here there is another video that I will tell what I was showing. Starting from a teleoperational stuff, that was the first part of the video. You manually drive on Isaac GROOT the robot, you grabbing the things, you training a network, and on the second part, you can drive, the robot is moving and is able to pick the object and moving autonomously. The final part, but not at least not the really important, is making all the software running on the real robot. And we have the Jetson Thor, recently released, support on the Ubuntu 24.04, Ubuntu 24.04, extremely performance with a Blackwell GPU. Many more cores, there are many more GPU, GPIO to drive, example, all motors and controller on the robot, and is specifically designed more for humanoid robots. And same story for Jetson. There are many partners are working with us, camera makers, open source company as well, software companies, hardware designer, and make the ecosystem bigger. You can work easy and define your robot, your application with different type of other software on Jetson.